Hello, Assalamu alaikum, sir. My name is Taskin Mustafa Ajam. My ID is 181151790. Today, our presentation topic is machine learning approach to classify birds on the basis of their sound. Today, our presentation member are Mazharul Islam Rida, AKM Sifatullah, and Khalid bin Hassan Sarkar. Abstract. Bird classifier is a system which will use machine learning approach and allow user to record bird sound and identify them. The system will help bird species to identify by dropping in input only the sound of that bird. The framework also offers tools for translating some annotation into datasets that can be used to train a computer to identify a species presence or absence. Dataset recorded are dataset recorded are pre-proposed to remove unwanted noise and divided useful sound in frames so that it can act as an input to classify. The system was tested through different algorithm that have gave best result was chosen for implementation. System user audio feature like MFCG, that's means MFCG, melt frequency coefficient, etc. The system will use different algorithms such as KNN, random forest, multi-layer perceptron bias in classification of bird species. And introduction, there are approximately 15,500 birds species in the India, and even more when the consider the subspecies. But from a essential part of ecosystem, and it's important to identify them as an effort can be made to create ecological hotspot for the engaged ones. From the start of 20th century, 20th century witnessed widespread decline in the population of bird talking, and few of them were at the verge of extinct. Hence, efforts were made by various government and well-known personalities in the form of campaigns, advertisement to save bird, which made of the issue of bird conservation to reach mass, especially the youth. People are more curious about bird watching and conservation movement from than they were before. Human ear is able to perceive and discern more of the sounds there from their source. The creeping of bird is one such noise that occur in our natural environment that is not easy to differentiate just by listening to it, and therefore a software-based solution that help to recognize even bird species and allow them to learn more about them. Thank you, sir. My next presenter is Mazharul Islam Rida.
Hi, my name is Mazharul Islam Rida. My ID is 181151799. Here I am going to discuss about literature review and proposed design. Here, conduct a literature survey to find out what all work had been done in this field and what tools are needed to go ahead with the system. The survey gave us insights about the features required to classify the bird sounds and which models are needed for training to move further. Here, a term which is MEL frequency spectrum. In sound processing, the MEL frequency spectrum is a representation of the short-term power spectrum of a sound based a linear cosine transform of a log power spectrum on a linear non-linear MEL scale of frequency. The process of extraction of different features and selections of MEL frequency spectral coefficients to give input to the support vector machine SVM, as it give decent accuracy of about 89.64%. Extreme learning machine ELM are used to model emotional perceptions of audio and video features. ELM is used as an alternative to single layer feed-forward network for fast and accurate learning, a good open source tool for accuracy of the model. The processing that is done on the number one, the application of modality specific extreme learning machines to identify emotions in the wild. This paper proposed extreme learning machine ELM for modeling under unregulated conditions, audio and video functionality for emotion recognitions. OpenSmile versatile and quick open source audio extractor. OpenSmile is a voice processing and music information retrieval tool that allows researchers in each domain to be benefit from features from other domains. Automatic large-scale classification of bird sounds is greatly improved by unsupervised learning of features. This paper discusses and determines what characteristics should be taken into account. It also indicates whether or not noise reduction should be done as a pre-processing stage audio windowing to make a classification decision. Species-specific audio detection. They have presented a web-based cloud-hosted system that provides a simple way to manage large quantities of recordings with a general-purpose method to detect the presence of bird species in a recording. Classification of large-scale bird sound using convolutional neural networks. This paper addressed the attempt to use convolutional neural networks to classify bird speech. They developed audio spectrograms and provided them as input to neural networks. Based on their sound patterns, environmental prediction and classification of birds, they worked here to map on their sounds the characteristics of birds such as scale, locations, species and call forms. Here the proposed design. We can see a diagram which is the proposed design. The architecture of the project would include a client-server type of architecture. This is the client-server side where we can see an Android device which can record a sound. The sound will be received from the interface device, from the interface device to the computational server by an API endpoint. Simply put, an endpoint is one end of communication channel. When an API interacts with another system, the touch points of these communications are considered endpoints. API means application program interface, endpoint means the sound. Will then undergo some processing. It will undergo resampling. The resampled audio will be classified against the trained model. The output along with the probabilities will be given to Android client device. The main part of the system is training model and detection. This includes template. Computational model undergoes feature extraction including training recording together. Classification algorithm is applied and given to the detector. The detector takes clean recording of the input and extracts its features and compare it with the input from model trainer, then decides the result. Thank you.
Hello sir, assalamu alaikum. My name is Akem Sifatullah. My ID is 181151772. I'm going to discuss about the main work of our paper. So in any machine learning model, the first step is to data collection, to collect the data. So first we collect the data of the birds. Then the data was refined by the open source software Audacity. So by refining, we cancel the background noises and we make 100 such clips of 2-3 seconds for each bird class, and all of them were used further for feature extraction process. Then the second part of our machine learning model is data pre-processing. In data pre-processing, we have feature selection and feature extraction. So in general, what is feature selection? Feature selection is suppose we have many features in our data, all the independent features, and from all those independent features, some features are very valuable to predict our final result or the dependent variable. So we chose those valuable features for higher accuracy. If we choose all the features, there may be a situation creates that the accuracy will be low. So we choose the valuable features for higher accuracy. But in the case of the bird classification, we have 34 features and we have selected all the features because all the features together giving us the higher accuracy. Here we have all the features in the table. Then we have feature extraction. So what is feature extraction? Feature extraction is that we have all the features together. Suppose we have 34 features, and we create more features, or we extract information from the features we have already. So it means that we are creating more features. That means we are creating more features and deriving more information from our features that we have. So in this case, the BART classification case, what we have done, the audio signal is first divided into short term windows, frames, and all 34 features or functions are calculated for each frame. Out of the widely accepted range of 20 to 100 ms, we have selected window size of 20 ms for short term statistics, and for mid term statistics we calculated the mean as and standard deviation of the short term features. The result of short term features extraction are in 34 columns and n rows, and the result of mid term feature extraction are in 68 columns and n rows. After that we should visualize the data. That's the next thing to do in our any machine learning model. Since in the feature extraction we have seen that our data is multidimensional. We have at least n rows and 64 columns. It's huge. So we cannot plot data very easily. It's not possible to plot data which is a multidimensional data. So what we have done, we have used an algorithm called principal component analysis, or PCA. It's used for dimension reduction process. So we have reduced the multidimensionality of our data and made it into 2D data, and we have plotted it by the help of Python library, Seaborn and Matplotlib. Here you can see the plotted data. It's a scatter plot. So after plotting the data, we are seeing that the data is not linear. It's a non-linear data, and we'll keep it in mind for further process. After that, the main thing of a machine learning model is to training the model and selecting model. So in model training section, at first we have to select an algorithm. So from our survey, select algorithm. So from our survey we have selected 3 algorithms: the KNN, the K nearest neighbors, random forest, and SVM. We are that known as support vector machines. So these 3 algorithms were selected for which are better for the non-linear data set, and we have divided the data set into training and test section in a ratio of 90:10. So the training data, by the help of training data, we will train our algorithm, train our model, and by the test data we will test the accuracy of our model classifier. So after that we have seen that the support vector machine gave us the best accuracy. So among the three algorithms that we have selected for our machine learning model, among the 3 of them are KNN, random forest, and SVM. The SVM is giving us the highest accuracy. So after algorithm selection, to furthermore acquiring accuracy, there is a called hyperparameter tuning, which will help us to gain more accuracy of our model. So to avoid overfitting of the data in the SVM, parameter C was kept varied for few standard values, and for each value of C, accuracy and F1 score were plotted. The selected C value was 10. So what is overfitting? We are doing so much for the overfitting. Overfitting is a situation when, suppose, our machine learning algorithm or machine learning model is giving us a higher accuracy for our training data. So which data we have used to train the model, but whenever we give the machine learning model a brand new data that it has never seen before, it giving us a lower accuracy. So that's the situation called scenario called overfitting. So to avoid overfitting, we are using hyperparameter tuning. There can also be a question, what is hyperparameter tuning? Hyperparameter tuning is that we have so many parameters in our machine learning model, machine learning algorithm. layers of neural network, we have thetas, that thetas also known as the weights of the machine learning algorithm. So those are the parameter, and we select a set of parameter which will control the learning process. So that's how we are able to control the learning process and avoid the scenario of overfitting. After that, the last process, the classification. So after all those training the model and testing it, how we classify the birds? First, we divided the input audio file into audio file of 3 seconds with 1 second of overlapping windows. For each audio file, we have predicted the bird with the trained model. For each audio, it gives us the probabilistic result for each bird. By taking the average of each small probabilistic result, we have predicted the actual bird from the whole audio file. That's the main point, the main work of our paper. That's all, sir. Assalamu alaikum.
Assalamu alaikum. This is Khalid bin Hassan. My ID is 181151789. So let's start. Results. The support vector machine with radial basis function produced the accuracy of 96.7% during classification of the main classes and about 96% to 99% while doing the subclassification based on call or song of the classified bird species. The model was able to accurately identify the main as well as the subclass of the audio file given to its input through the application. The time taken by the server process the file and the return response was around 10 milliseconds to 20 milliseconds for our audio of 5 seconds to 7 seconds. This is the diagram of confusion matrix for primary classification using SVM. Conclusion. After analyzing the thesis paper, we came to know that we successfully find the primary classification models of distinctive bird classes. Though there are some bird classes that doesn't find any differences for lack of data sets and unavailability in research. Ornithologists and bird enthusiasts trying to adopt this model accordingly. Motivation. Subset of artificial intelligence (AI), machine learning (ML) is the area of computational science that focuses on analyzing and interpreting patterns and structures in data to enable learning, reasoning, and decision making outside of human interaction. Simply put, machine learning allows the user to feed a computer algorithm an immense amount of data and have the computer analyze and make data-driven recommendations and decisions based on only the input data. If any corrections are identified, the algorithm can incorporate that information to improve its future decision making. Data is the lifeblood of all business. Data-driven decisions increasingly make the difference between keeping up with competition or falling further behind. Machine learning can be the key to unlocking the value of incorporate and customer data and enacting decisions that keep a company ahead of competition. That's all. Thank you.